Back guys, today we'll be learning about calculus of functions of several variables. So today we'll be learning about repeated limits and double limits. So first is repeated limit. So let me first define it. The repeated limit of fxy as x tends to a and then y tends to b is given by, here this is important, first x tends to a then y tends to b. So what this means is that limit y tending to b then limit x tending to a f of x comma y. So first we need to evaluate the limit by putting x tending to a. So this will be limit y tending to b, some function which will be converted in function of y because we have already put the value of x. So and then again putting the limiting value of y, we get some limiting value L1 let, and the repeated limit of fxy as y tends to b and then x tends to a is given by limit x tending to a limit y tending to b f of x comma y is equals to limit x tending to a then some function of psi x which will be equals to at last L2. So these two are the repeated limits when x tending to a at first and then y tending to b at first. Now let us learn about double limits. So double limits is simple. It is just the limiting value when x tending to a and y tending to b simultaneously, which will give a limiting and finite value L. So this is known as the double limit or the simultaneous limit. So to understand this, let us see a example or question. So we need to check whether the double limit and repeated limit exists for the function f of x comma y at x plus x minus y upon x plus y and 0 xy not equals to 0 comma 0 and xy equals to 0 comma 0. We need to check this at x at 0 comma 0. So first we need to do, we'll check the repeated limits. So first x tending to 0, limit y tending to 0, f x comma y, that is equals to, so this will be x minus 1 and this will be x plus y. So this will be putting value y, we get x upon x, then putting limiting value we get 1. As this gets cancelled, this is 1, and for the second case this will be something like this. So this will be minus y upon y, this will be minus 1. So here we see that the repeated limits do exist but they are not equal. Repeated limits exist means that the answer, the limiting value is a finite value. So the repeated limit exists but are not equal. So now we will see the double limit. So to calculate the double limit, we need to assume this is the basic condition. We need to, for the given point for which we have to find a double limit, Now for finding double limit, we need to choose a value for or path for y which which when we put in terms of x, that whole term will be independent of x. So what I mean is that let xy tending to 0 pass through the path that is y equals to mx. So therefore in limit x comma y, that is 0 comma 0, f of x comma y, that in turn is equals to xy 0 comma 0, x minus y upon x plus y. So this will be, so now we will put the value of y in terms of x. So this will be x minus mx and this will be x plus mx. Now taking x common, we get limit x tending to 0, 1 minus m upon 1 plus m. This will be 1 minus m upon 1 plus m. Thus we see that for different values of m, we get different values of m, we get different values for the function. So the limit does not exist, the double limit does not exist. So for double limit we need to choose a path for y for which the function will be independent of m, and if for all values of m we get the same answer, then the limit will exist. Suppose if we put m is equals to 1, then this will be 0. If we put m equals to 2, we get minus 1 upon 3. For all values of m we are getting different answers, so the double limit does not exist.